Hello students, this is continuation of previous video chapter 0, and also in this video we will start chapter 1. We will look at some concepts and do some problems. Now in chapter 0 we talked about different concepts. So the rules of exponents, the product rule, quotient rule, first power rule and other power rules. Also we looked at scientific notation, some algebra concepts, trigonometry and graphs. Now I want to do a simple problem from chapter 0. So this is about proportionality. So here if x is proportional to y and x is equal to 2 and y is equal to 10, what is the value of x when y is equal to 8? Okay, so this is a simple proportionality problem. Okay, so it says x is proportional to y. Okay, so we write in this way. This is the proportionality symbol, right? So this says that both x and y quantities are directly proportional. That means if one quantity increases its value, the other quantity must also increase its value. If the y value decreases, then x must also decrease. That's what it means by direct proportionality. Understand? Now if you remove this proportionality symbol, you just need to add a constant here. Okay, so x is equal to a constant k times y. Okay, so this is our equation. Okay, right. So now let's substitute the values to find the k value, constant. Okay, so k is equal to x divided by y. Okay, so that means 2 divided by 10. Okay, so that is equal to 1 divided by 5, right? So the k value is equal to 1 divided by 5. Okay, now we need to find out x value when y is equal to 8. Okay, so again use this equation. So we are finding x value. Okay, so y is equal to 8. This constant value is not changing, right? So constant. So 1 divided by 5 times y value 8. So this is 8 divided by 5. Okay, so that's the x value when y is equal to 8. Understand? So this is how we solve this kind of problem, proportionality. Okay, very simple if you understand how to write this equation. Okay, now also learn how to plug in values in a scientific calculator. Understand? If it is just a simple division or multiplication, you can easily do in calculator. But if the expression involves several quantities in the numerator and denominator with different operations like addition, subtraction, multiplication, division, then you must use parentheses carefully so that you get the correct answer. Understand? So just as an example, try this expression here. Okay, substituting x equal to 2, y equal to 3 here. So this will give you the correct answer if you write using parentheses. Based on facts and using mathematics, scientists develop theories. Okay, to verify these theories, we must conduct experiments. Okay, so experiments are very important in physics. Okay, physics is an experimental science. To conduct an experiment, we must do some measurement. Every experiment involves some measurement. Okay, so we measure physical quantities. Okay, so any quantity that can be measured is called a physical quantity. Okay, now there are so many physical quantities. Okay, some of them are distance, speed, time, velocity, etc. Okay, because we can measure these quantities. Understand? So once we take our measurements, we do calculations and analyze data so to get the final result, and using that final results we verify the theory. Okay, in mechanics there are only 3 fundamental physical quantities. Okay, so those are length, mass and time. Now physical quantities are divided into 2 categories. So scalars, they are scalars, and vector quantities. Okay, so scalar quantities have only magnitude. Okay, but vector quantities have magnitude and direction. Okay, so here no direction, but vector quantities have both magnitude and direction. Okay, so whenever you are expressing a physical quantity, you must specify both magnitude and direction for vectors, right? So I will give you some examples of vector quantities. Okay, so displacement, velocity, acceleration, okay, force, momentum, impulse, etc. So these are all vector quantities. Okay, that means whenever you are expressing these quantities, you must specify both magnitude and direction. Okay, scalar quantities have only magnitude but no direction. Understand? So examples here are distance, okay, speed, right, next area, volume, temperature, time, etc. Understand? So these are all scalar quantities. They have only magnitude. The weight of a rock, for example, is, let's say, 10 pounds. Okay, so this 10 pounds here. Now this 10 is the magnitude and this LB is the unit. Understand? So this is the unit of the quantity weight. Okay, so this is the magnitude we are talking. Okay, so this number here is the magnitude and this is the unit here. Understand? Now in mechanics we have only three fundamental physical quantities. They are length, mass and time. Okay, now whenever you express a physical quantity, remember you must specify the magnitude, unit and direction if it is a vector quantity. If it is a scalar quantity, only magnitude and unit. Understand? Now for a vector quantity, let's say you are traveling with some velocity, let's say 50 miles per hour in east direction. So this is your velocity here. Understand? Now this 50 is the magnitude, miles per hour is the unit of velocity and east here is the direction. Understand? So this is how you express the physical quantity. Understand? So remember these three fundamental quantities, very important. So the length, mass and time. Okay, so length units, all these three quantities are scalar quantities. They have only magnitude and unit but no direction. Understand? Right. So the length units are meters, centimeters, inches, kilometers, miles, etc. There are different systems you can express the units for these physical quantities. Understand? Now, so let's look at those systems here. Okay. We said the length, three primary physical quantities, length, mass and time. Okay, so these are called primary physical quantities. There are many secondary quantities which can be derived using these primary quantities. Okay, so there are different systems using which you can express the units. Okay, so for example, the first one is SI system, or this is also called as MKS system. Okay, SI means international system, MKS which is meter, kilogram, second. Okay, so both are same. For the length we use meters. Okay, for mass we use kilograms. You see, meters, kilogram, second. Understand? So this is second. Now there is another system, CGS system, centimeter, gram, second. Okay, so this is centimeters, this is grams and this is seconds. Understand? And there are FPS, British system, etc. Okay, we just need these two systems. Almost all problems we do this semester, we follow the SI system. Okay, unless problem specifically asking you for CGS units, by default we use SI system. So in some problems you may require to do the unit conversions. Okay, so sometimes the value may be given in centimeters, then you need to convert into meters, SI system. Okay, to do that unit conversion we use conversion factors. Okay, unit conversion factors. Okay, so now the unit conversion factors are already there in your formula sheet. Okay, so let me show you. So you see the unit conversion factors. Now 1 meter is always equal to 100 centimeters and it is always equal to 1000 millimeters, right? So this is a conversion factor. And also if you look on the right, you see the metric prefixes. Okay, so we use them a lot in our daily life. If you, for example, if you purchase a cell phone, you look for the memory memory storage of that phone, right? So let's say you are buying a phone with 64 gigabytes. Giga is a prefix which we use in front of the unit bytes. Okay, so memory units are bytes. Okay, so and we use this prefix giga in front of the unit. Understand? Right, and these values are specific here and they are standard universal. Okay, now you see kilo means always 10 to the power positive 3, mega means 10 to the 6, giga is 10 to the power 9, and so on. Okay, and if you have the number with a fraction of 10th or 100th or 1000th, you have the prefixes deci, centi, milli, micro, nano, etc. This is problem number 1 in chapter 1. The problem says how many ohms are there in a 7.85 mega ohm resistor. Okay, 1 mega is equal to 10 to the power 6. Mega or million means 10 to the power positive 6. Okay, so 7.85 mega ohms, right? So that's the unit, 7.85 is the magnitude. So this is equal to 7.85 mega means 10 to the power positive 6 ohms. Okay, so the question asks how many ohms are there in 7.85 mega ohms. Okay, so 7.85 times 10 to the power positive 6 ohms are there in that resistor. Next one, typically laboratory capacitors are around 5 picofarads. How many farads are there? How many farads means you just need to convert the pico, which is a prefix, into the number. So this is 5 times 10 to the power pico is 10 to the power negative 12 farads. Understand? So this is 5 times 10 to the power negative 12 farads. So similarly you can solve other problems. Okay, right? So we will do more problems in the next video. I stop this here.